Hi guys, welcome to our channel of Sciences and Mathematics. Today's discussion is basically going to entail a short concept of on enthalpy, and that is enthalpy notation. Now this concept is going to assist us be able to illustrate specific maybe reactions that entail the taking in or release of heat that we refer to as exothermic or endothermic reaction. So for that case, thank you and welcome. So our topic of discussion today, as I've said, is going to be complement on what we have already discussed, and the concept of endothermic and exothermic reaction. Basically, it's going to entail enthalpy notation. Now, these concepts of notations that we are specifically talking about are very relevant for us because it gives a general, maybe a universal representation in which we are able to understand. We are going to be able to understand what chemical reactions represent, or specific symbols which accompany chemical reactions involve. So in this case, as we have already discussed about the concept of exothermic and endothermic reactions, we say that both reactions involve either the taking in or release of heat from the system to the surrounding, or from the surrounding into the system. So in this case, the heat energy, or the energy that is involved in or maybe which is possessed by a chemical, is very important, since it's going to dictate the nature of how these chemicals are going to behave. So in this case, we are going to look at specifically this concept of enthalpy notation by first understanding what the term enthalpy is. Basically, we've already discussed about it, but I'm just going to give it a short brief for that case. So this enthalpy refers to the chemical the heat content of a chemical. So shortly, or maybe briefly, we can just give a brief definition for that as heat content in a chemical. Just specifically, heat content in a chemical. Now this heat content in a chemical, we have given it a denotation somewhere in one of our videos, which is given as capital H. And this heat content of a chemical is very essential, but we cannot be able to measure this heat content of a chemical. But we can be able to measure the change in the heat content of a chemical that we refer to as delta H. So this delta H that I've written is what we refer to as change in enthalpy. So as we have said that enthalpy is denoted by which is the heat content in a chemical, is denoted by H. I've said that we cannot basically be able to measure the heat content of a chemical, so therefore it's easier for us to note the temperature change, maybe when the chemical is taking part in a reaction, or maybe the change in energy, which can be, of course, given as delta H. Now, for us to achieve this, we are able to take the differences in temperature between the time when the chemical reaction starts and when it ends, or maybe when there's a different changing states, like maybe dissolving a substance to form a liquid. So in this case, this concept of delta H is dealt with appropriately using the change in temperature. And there's an equation which is we're going to use in order to represent this enthalpy change, which of course involve in any chemical reaction we have reactants which are forming product. So therefore, if it involves the change in heat energy, then therefore we are going to represent this change in energy in this process using the concept of delta H. So in an equation form, we can write enthalpy change, which we have given as delta H, can be represented as enthalpy of products. So it's the difference between the enthalpy of product and the enthalpy of reactant. So that's an equation that is going to represent the change in enthalpy. And as we said, this delta H is a form of energy. So therefore, you can be able to use this equation for the delta H, which is enthalpy of product minus enthalpy of reactant. So in an equation form, that's how we can be able to represent the enthalpy change. So this basically builds up the concept of enthalpy notation that I was trying to talk about, from the representation of enthalpy as H, the change in enthalpy, which is, of course forms a relevant part of a discussion about that change in energy. And now in this case, of course, this is basically shown in stoichiometric equations, especially at the end of writing those equations. And we can be able to give maybe an example of that to illustrate the same. So therefore, whenever a chemical reaction is taking place, we can give a denotation or maybe a denotation for the change in energy or maybe change in enthalpy using that specific symbol. Now, since that one is quantified as we talked about the energy being measured in joules, we can be able to give a figure for that specific reaction. Now, suppose we have a reaction for formation of ammonia using nitrogen and hydrogen. So this is going to form ammonia. So this one I can write to there at specific point. So this is a balanced stoichiometric equation whereby the states for these reactants and the product, the gaseous state. So I'm going to write the change in energy which is involved in this specific reaction. It's negative 92.8 kilojoules. So therefore, apart from writing this stoichiometric equation for the formation of ammonia, I've included some information in front of the equation, which is negative 92.8 kilojoules. So as we said, whenever there is an accompaniment of a negative sign, then that means that the reaction is exothermic, and it involves a release of heat from or a decrease in the heat of the product, and therefore we are going to have a negative sign illustrated as above. So maybe I can give another example in order to illustrate how we can be able to denote that enthalpy whenever we are trying to write stoichiometric equations. So suppose there's a combustion process that is taking place where methane is undergoing combustion to form carbon 4 oxide plus water. So first of all, we check whether the equation is stoichiometric, and we're going to have two coefficients which is going to ensure that the equation is stoichiometric. So this is how the reaction takes place. So I'll put a enthalpy sign there to indicate the amount of heat that is involved. So this is 728 kilojoules. So basically that's the heat that is involved in the combustion, this process of combustion of that is methane to carbon 4 oxide plus water. It's accompanied by this. So in an essence, when we are trying to write an enthalpy notation, it accompanies a stoichiometric equation by using this delta H and then indicating whether the reaction that is taking place is involves the release of heat with this specific figure for the quantity of heat that is involved in that specific reaction. So basically this is how we can be able to illustrate the enthalpy notation. Now from understanding the concept that the heat content of a chemical cannot be measured, but the change in temperature which accompanies, or of course the change in energy which is accompanied by the change in temperature is the one that is going to assist us to define the delta H. So therefore, this is how we can be able to illustrate this enthalpy notation whenever we are trying to write a stoichiometric equation. I hope we have understood on how we can be able to illustrate enthalpy notation that is accompanying the stoichiometric equation that we have illustrated by example on the board. So that is it for today, guys. Bye. God bless.